I heard word radical over there. I have to blame my friend Lars-Erik Mattila. I'm here on behalf of him. He just became a father, and this is the reason. His project, Multi-storey House of the Future, is in a way radical, I think. I was luckily able to stall his slides, put some of my own in between, and divided the short presentation in four parts. Let's start with the Johan Rockström's parameters, 9 parameters of planetary boundaries. Let it be forest loss or ozone depletion or anything, the curve is always the same. Something radical happened in 50s after the war. Then, when we take a look on the architecture and the ecological architecture, we mainly focus on these three things. They are branches of the tree, big tree, and when we focus on these, cut these down, others still keep growing. The human touch and the major reason for all the curves bend up, I think, is the raw material extraction. The population in a little bit more than a century have expanded 4 times, but the consumption of raw materials have tenfolded. Construction minerals is the biggest issue. We use them 42.5 times more than about a century ago. Taking this down will take all the other parameters down too. This is Alan Organski's graphics from Yale University. This tells something about the differences between the material resources. That's also a key issue, of course. On the left side of the graphics, there's natural resources, part of the organic cycle. Harvesting of the forest is little like cutting a hair. The quality of the material, it still is natural, part of the cycle. And as it's best, it is ready to take to the site as it is. Then we have clay, rocks, etc., deep minerals, and at the extreme right, oils and gases. Harvesting the oil could be a little bit like drilling a skull. Drop of oil, when it becomes on Earth, it's a poison. Single drop of an oil can destroy huge amounts of fresh water. And right-hand side materials are ready for heavy processing, not on the construction site yet. Building stock. Again, something happened during the 50s. Before, the buildings were already natural. We used brick, solid wood, so on, and product range was around 500. After that things got a bit complicated. Building a house used to be easy, now it's not. And basically, nothing have changed when we reached this millennium. But of course, the amount of products, 55,000. Again, after 50s, energy consumption was at its peak. It started to come down, and we are quite on a low level at the moment. Achievements gained with the super insulating buildings are unfortunately ruined a bit when loading the buildings with the huge amounts of technology like HVAC system and all the active systems. But the remarkable thing over here is that we are on the same level than where we were 100 years ago. Not 100 years ago, these monitorings have been done a few years ago, and this is the existing situation. Old buildings just consume less energy. at least in Finland. Another change, building built in the beginning of 20th century. For some reason, it just keeps going on. It's natural, it's maintainable, but again, big change after the war. Lifetime expectancy of the buildings dropped down, and we are in a situation that we keep building buildings for 50 years, maybe 75 if we are lucky, but then we take them down, take them away. Buildings became disposable. We could imagine, for example, central Paris without these old buildings. If we would have always been building buildings like we do today, we would not have such a beautiful city centers all around Europe. Recycling rate after the building dies. This is an EU aim for 2020, 70%. That's quite a challenge, and actually I don't have any idea where are we now. But I have an example of world-class recycling system. This is a PET plastic bottles in Finland. The recycling rate is huge, 92%. But what is interesting over here is the 8%. It means 31 million bottles is leaking off from the system every year, somewhere to the nature, I don't know. And in 12 and a half years worth of bottles are lost. Sad truth is this: everything goes to the food chain on our plates, not only plastics, but all the weird stuff in our buildings at the moment. It must have some nasty effects, and it has. Big part of the compounds that are harmful for the nature are harmful for us. Architecture is basically, and in a first case, it is what we breathe. It is totally normal that the Western office worker spends 90% of his time inside, and the list on the right is endless. 55,000 materials, all mixed together with weird compounds and everything. The safety zone on the right-hand side is really narrow, but it's natural and it's easy. It tells that as an architect, we are in quite a happy situation that we have a solution. We can pick the healthy materials, and on many industries, the situation is not the same. We need a cold turkey, and it's the multi-story house of the future. Just nothing special, double slope roof, glass facade towards the south, and the balconies. But what it is and what it's not. The building today is a complex thing which dies young. For some reason, it is legal. Building in the future seems much more rational and more logical, but it's illegal. It doesn't pass the electricity efficiency, or should I say greenwash calculations. Not even if it succeeds in a long span really well. Even if the building would be a zero energy building, but the lifespan is short and the materials are fully processed, the situation is really bad. Every 50 years, a lot of waste is produced, a lot of energy is consumed when building a new building every time. But multi-story house of the future just keeps going on, mainly because it's simple and it's maintainable. This is the materials of the multi-story house of the future. Left side, green is solid wood, and pink color is clay-based materials. This is a theoretical calculation on the right side of the image. The main point is the areas with black dots. All that with today's methods is harmful when taken into nature. The frame of the building is solid wood, no glue, no additives, only mechanical joints. These both products are on the market in Germany. Vertical frame is a little bit like a CLT, we all know today, but with the mechanical screw joints, the pegs that are holding those boards together are wooden screws. And the horizontal frame, all the slabs are so-called Brettstapel structures, just planks of sawn timber bound together with wooden pegs. Section of the building, foundation, totally an ancient stack of natural stones put together. Bottom of the building is ventilated. It's just as a buffer zone preventing all the moisture and everything touching raising up to the building. The frame was wood. The corridor spaces are covered, fire protected by a clay boards, clay and natural textile combination. And the attic, that is another buffer zone, which is maintenance space in a way that when you notice that the roof starts to leak, you are ready to do something. Nothing is hidden, everything is visible. And the roof trusses are medieval trusses, round wood, tapering in the other end. Just the sides of them are sawn straight, all the joints, wooden pegs, but they cannot be used today because engineers don't know how to calculate them, even though there's a lot of evidence all around the world that they work for centuries. Ventilations, no machines, just the natural ventilation. District heating with the radiators. All the assemblies are visible, so they can be maintained. Fire protection, additional one, is a sprinkler system all over the building. Compulsory interior images, but the remarkable thing perhaps over here is the aim to leave all the surfaces untreated. Just wood, just the frame material, nothing else. And another interior, if the building would be used as an office. And the back. Thank you.